Now, one thing that you have to know about piecewise functions is that this part gives you the formula, where there's another one which are the condition. And you're supposed to evaluate the formula only when the condition is met. So what I'm trying to say is that, for example, if you're asking what's f of 0, well, if you plug in 0 here, you get 1, whereas if you plug in 0 and you get 0. So which one is it? Should it be 1 or 0? It should be 1, because when you plug in 0, that means you're setting x as 0. That's what it means, right? Since it's a f of x, if you plug in x equal to 0, then immediately you look at these conditionals. Is 0 less or equal to 2? Yes. Is 0 bigger than 2? No. Since this one's true and this is not true, then you go for this one. And you get 0 plus 1, which is 1. That's why it's that's why f of 0 is 1. You get that? Okay. Let's see if you understood what I was just saying. What's f of 4? Okay. That means x is 4. Is 4 less than 2? No. How about 4? 4 is bigger than 2, right? So we follow this formula. Since it meets this conditional, you follow this formula. What's the value? Negative 4 squared. What's that? Negative 16. Okay. This negative is outside the square, okay? See, negative 4 parenthesis squared is positive 16. Negative 4 squared is negative 16. You have to know this difference, okay? All right, so knowing that, now the second question is, how do you sketch this graph then? Here's how you sketch the graph. First, you start off by sketching both of the graphs on a single axis. So first of all, what's the graph of y equals x plus 1? This is a slope 1, y-intercept 1 line. It's a line equation, right? We know that mx plus 1, mx plus b is a line whose slope is m and y-intercept is b. So b is 1 and slope is 1. All right. So you start from y-intercept 1, and because slope is 1 and that's rise over run, you can think of this as 1 over 1, okay? Which means you rise by 1 and you run by 1. So that's the next point. If you connect them, you get this straight line. Okay, so that's the graph of x plus 1. Now let's try to draw the graph of negative x squared. Well, what's the graph of negative x squared? It's a parabola that opens down, right? Because it has a negative power. So the graph of negative x squared will be more like this. Okay? Do you agree? All right. Now, one more thing that you want to do anytime you draw a piecewise function is always evaluate these functions at the boundary. So 2, before 2 and after 2 is a transition between these two functions, right? So you want to plug in 2 to each one of these to see what's going on. So if you plug in 2 into this function, what is this coordinate? If you plug in 2, what do you get? Here. 2 plus 1, you get 3. You get 3 here, right? And then if you plug in 2 into this one, what do you get? Negative 2 squared, which is negative 4. So you get negative 4, and it's here, okay? Okay. So that's what you get. And then, now let's think about which one should be valid. Before x is 2, before 2, when x is less than 2, over on this side, which one should I erase and which one should I keep? Which one should I get rid of? Which one should I keep? We get rid of negative x squared, because when x is less than 2, it's the x plus 1 that we follow, right? So we delete the negative x squared until you hit negative 2, okay? And then we keep the line because this one is x plus 1, right? Is that good? After 2, which one do we keep? The line or the parabola? It's the parabola. It's this one. We get rid of the line and we keep this, okay? So the end result is that we have something like that and then this.
Wait, what? Wait.
Why? Why? What's wrong?
Why you get half? How do you get half of a parabola?
Oh, because you don't get the full picture. You only get the picture after 2. So I've drawn a parabola. But then after I deleted everything before 2. So this is the only thing that survived.
Let's say I got a question.
Yes.
So let's say it was -1 on top.
Yeah.
It would be -1, and then it wouldn't exist over there to the right side. It's just x plus 1.
Yeah. If this was 1.
-1. I'm talking about -1.
-1. If it was -1, then only this portion will be kept, and the entire thing will be deleted. Yes.
So that says x is less than or equal to 2, right?
Right, that's the second point. So this is not fully correct. Now you have to think about what happens at 2.
Okay.
All right. So at 2, what's the actual value of f of 2? F of 2 is? It's this one, right? It's 3. It's not -4. So the actual value of 2 is 3. So we put a closed circle, and this is no good. So what do we do here? Huh? If it's no good, what do we do? You erase it and put what? Put an open circle. Thank you. Yeah. You put an open circle. Yeah. Yeah. That's how it works. Let's do another example. Yeah. Okay, first of all, what's the graph of y equals to 1 minus 2x? Well, think of it like -2x plus 1, so that the slope is -2, or you can rewrite this as -2 over 1, which means rise is -2 and run is 1, right? And what's the y-intercept? 1. This is the y-intercept, right? So you're going to have 1 as your y-intercept, and then what you need to do is you go 1, 2 down for your rise, and run would be 1. So that's your next point. And then you connect it. That's the graph. Is that good? All right, good. And then what's the other graph? Y equals to x squared, right? Yeah, something like this. Now, what's the dividing line? Before and after 1. Before and after 1, right? And what you need to do is you have to plug in 1 to figure out the coordinates. If you plug in 1 here, what do you get? Because it's like before and after 1, right? Yeah. Okay. So if you plug in 1 to the first equation, what do you get? -1, right? So this point right here will be 1 comma -1. If you plug in 1 here, what would you get? 1 comma 1, right? Right here. Okay? All right. So let's now think about what happens before and after 1. Okay, on this side, which one do you keep? The parabola or the line? On this side, on the left side of 1. On the left side of 1 is this, right? You keep the line. The line is over here. Keep the line. Parabola is gone, okay? All right. On the right side of 1, which one do you keep? You keep the parabola and you delete the line, right? So the end result is this. Well, almost the end result. We still have to figure out what happens exactly at 1. It's like this and then this. Okay. However, what happens at 1? Should I put, which one's invalid? It's like the fake value. The line one, this value is invalid. So this is an open circle, and this is a closed circle. And that's the correct answer. Because at 1 is x squared. 1 is 1. What is f of 1? Should I use this one or this one? Well, this is clearly not right when x is 1, right? When x is 1, this one is the one that's true. So it's 1. So true one is 1 here, and this is the fake one. Yeah. Okay, try this last example. First, y equals to x squared plus 1. Let's think about this one. What is that graph? Well, y equals to x squared is this one, right? What does this plus 1 do?
Starts at +1. Like that's
It moves 1 up. It moves on 1 up. Okay, so let's say here's 1. The parabola gets moved up by 1. So that's what you get. Okay. Now, what about y equals to 1/2 x plus 3? Well, see, 1/2 is the slope, and that's rise over run, right? And what is 3? What is 3? Y-intercept. So this is 2, and then this is 3. That's your y-intercept. And you're going to do rise is 1, and run is 1, 2, right? Okay. And that's the next point, and that's your line. Okay. I also asked everyone to evaluate the function at this dividing point, which is 2. So what do you get if you plug in 2 here? 2 squared plus 1, 5. So at 2, this point will be 5, 2 comma 5 up here, where the graph passes through. Maybe I should really write it like this. Right here. On the other hand, this point here, if you plug in 2 here, what do you get? Half of 2 is 1 plus 3, which is 4, right? So this point here will be 2 comma 4. 2 comma 5, 2 comma 4. Okay, now since 2 is the dividing line, before 2, what should we keep? We should keep the parabola, because before 2 it's x squared plus 1, so we keep the parabola. After 2, what should we keep? We delete the parabola and keep the line, right? So graph would be like this. Now, which one should I put the open circle? Which one's open circle? This one's the open circle, right? The line has the open circle. And this one will be the actual solid circle. So that's the answer. Okay, that's all for today.